Hi, namaste everyone. Generally, we doesn't know why some people are very hard and why some people are very soft. But in our chemistry, why some chemical species are hard and some are soft can be known by the topic called HSAB, which means hard and soft acids and bases. So, myself, P. Manikya lecturer working at TSWRDC, W. Kamareddy. So, today the topic which I am going to discuss is hard and soft acids and bases. Under this topic, we are going to discuss four headings. Those are introduction to hard and soft acids and bases, and classification of metal ions and ligands, and Pearson concept of hardness and softness, and Pearson classification of acids and bases. If you go further, an application of HSAB rule, limitation of HSAB rule. The first is the introduction. In introduction, if you see, hard and soft acids and bases concept is abbreviated as HSAB. This is also known as Pearson acid-base concept, which was widely used in explaining the stability of compounds and to know the reaction mechanism and pathways. So, the stability of the metal complex depends upon the nature of the ligand and the nature of the metal. If you go for the nature of the ligand, it also depends upon the size of the ligand and charge carried by the ligand. And if you go for the nature of the metal, the stability of the metal complex depends if the size of the metal is small or large. So, in order to solve this, the metal ions and the ligands are classified by Arhol and Dave. So, here we can see the classification of metal ions and ligands by Arhol and Dave. The stability of the complex depends upon the type of ligand and metal ion. So, to solve this problem, Arhol, Chart and Daves divided the metal ions into two types or classes according to their preference for various ligands. So, metal ions and ligands are classified into class A, class B, and ligands are also classified as class A and class B. In briefly, if you see the classification of metal ions, which are also called Lewis acids, why these metal ions are called as Lewis acid means metal ions accept electrons from the ligands. So, the chemical species which accept the electrons from any species which is donating the electrons are called Lewis acids. So, metal ions are classified into two types. The first one is the class A or type A metal ions, and the second one is class B or type B metal ions. Now let us see which metal ions comes under the class A or type A metal ions. The first one is the alkali metal ions, that is from lithium to cesiums. These metal ions of first A group elements comes under the class A, and the second is the alkaline earth metals. Second A group elements metal ions comes under the class A or type A metal ions, and lighter transition metal ions which are in higher oxidation state, and also boron, aluminum, silicon, and metal ions with no d electrons are also comes under the class A metal ions. If we go for the class B metal ions, heavier metal ions in the lower oxidation state, example copper in +1 oxidation state and silver in +1 oxidation state, comes under class B metal ions, and also metal ions with lower valency, for example nickel in +2 oxidation state and palladium in +2 oxidation state comes under the type B metal ions. Here we can clearly see metal ions are classified into two types. They are type A and type B. And which metal ions include the type A and which metal ions include in the type B is clearly shown in this picture. And then ligands are also classified into two types. These ligands are called as Lewis bases. Why? Because ligands donate a pair of electrons to the central metal ion, So the chemical species which donate the electrons are called Lewis bases. So ligands are classified into two types. They are class A or type A bases, and the second one is class B or type B bases. So now let us see which ligands will comes under the class A or type A bases. So the ligands containing donor atoms of higher electronegativity and lower polarizability and have higher tendency to coordinate with the type A metal ions comes under the type A bases. So the ligands which contain the donor atom of higher electronegativity or lower polarizability and higher greater tendency to coordinate with type A metal ions comes under the class A basis. If we go for the class B basis, the ligands containing donor atom of lower electronegativity, higher polarizability and higher tendency to coordinate with type B metal ions comes under the class B basis. So if we see the tendency of the type A basis to coordinate with the metal ions, the tendency is as follows. Here nitrogen has greater tendency when compared to the phosphorus and so on. And similarly oxygen has more tendency than sulfur, then selenium, then the tellurium. So this is the sequence, and in class B the tendency to uh, complex with the class B metal ions is as follows. Nitrogen has lower tendency when compared to the phosphorus, arsenic and antimony. So here is the clear classification of ligands, nothing but Lewis bases. They are classified into two types, class A or type A bases, class B or type B bases, and which ligands comes under the type A and which ligand comes under the type B. So this is the brief classification about the ligands. So before going to our topic, that HSAB, I want to show the picture of an ore. That is, here you can clearly see the picture of hematite. Hematite is an oxide ore or an iron ore, and the next picture is sulfide ore, that is the zinc blend. So here the question arises, why iron forms only oxide ore, why not sulfide ore? Why zinc forms only sulfide ore, why not oxide ore? To explain this concept, Pearson has proposed a concept called Pearson principle or HSAB principle. Here he is the scientist who proposed the Pearson principle. This Pearson is used principle is used to predict the stability of metal complex. Pearson proposed this in 1963, and this is called Pearson HSAB rule. So according to this rule, hard acids prefer to form bond with hard bases and soft acids prefer to form bond with the soft bases. So if we see this principle in a pictorial manner, here it is very clear that hard acids prefer to bind with the hard bases and soft acids prefer to bind with the soft bases, and vice versa. Hard can bind with the soft, and also soft acids can bind with the soft bases. But the reverse is not according to the HSAB principle. And so why these chemical species are classified into hard and base? To know that, we have to know the definition of the polarizability. So if we see the definition of the polarizability, the capacity of a group of atoms in a molecule or in an ion to polarize its electrons is called the polarizability. Here the nitrogen, which is more electronegative species, will attract the electrons, and the hydrogen will donate the electrons are shift from the hydrogen to the nitrogen. As a result, nitrogen carries a partial negative charge and the hydrogen carries a partial positive. This is nothing but the polarizability, means the destruction of the electron cloud in the presence of an electric field is called polarizability. So depending upon the polarizability, chemical species are classified into two. one is hard and the other is soft. So what is hard? A less easily polarized species is called hard. Means that chemical species or that ion is not much easily polarized, that is called hard. And what is soft? The chemical species or an ion which can easily polarized is called soft. So the interaction between any two hard species gives rise to an ionic compound, and interaction between any two soft substances gives the covalent compound. So depending upon the polarizability, chemical species are classified into hard and soft. Hard means they are not easily polarized, soft means they are easily polarized. So depending upon these, Pearson classified hard acids into hard acids and soft acids. So these are the characteristics or the definition of hard and soft acids. If we first move for the what are the definition or the characteristic of hard acids: cations of smaller size and high positive size, and cations of lower polarizability, and cations of lower electronegativity and less valence electrons comes under the category called hard acids. These are the characteristics of hard acids. Acids itself saying that which donate the electron, means they will donate the electron. So these are the cations of smaller size and they have high positive size and low polarizability and low electronegativity and less valence electrons. And if you see the characteristics of soft acids, the cations of larger size and low positive charge, high polarizability, high electronegativity and more valence electrons. These cations which are having these five characteristics comes under the soft acids. Now let us see the pictorial presentation where we can see the how hard acids and soft acids can be seen. In this pictorial, from right to left, the electronegativity factor decreases. So the left side one are hard acids and the right side one are soft acids. If you move down the group from lithium to cesium, the size decreases. Lithium with the smaller size is hard acid, and cesium with larger size is a soft acids. In this picture it is very clear how where the hard from if you move from right to left, hard metal ions becomes very hard, and if you move down the group, the metal ions becomes very soft. So this is the brief explanation about the hard acids and the soft acids and their characteristics. And then if you go for the next definition of hard and soft bases, here hard bases means these bases ligands with the small size, high electronegativity, they are very hard to oxidize and they have low polarizability. These includes under the hard acids. So if I go for the soft bases, ligands with the large size, low electronegativity, easily oxidize, high polarizability. These are the characteristics of a soft bases. Here we can see the pictorial presentation. From nitrogen to fluorine, electronegativity increases. So fluorine with high electronegativity comes under the hard base, and nitrogen with low electronegativity comes under the soft base. Here it is very clear that from down the group, if we see the down the group from fluorine to iodide, the electronegativity decreases or the size increases. So fluorine is a harder base and iodine is the softer base. So these are the characteristics of harder bases and softer bases. So here you can see that broad classification of all ions into hard acids and soft bases. Here you can see the hard acids and soft bases. And here you can see that hard bases and hard bases and soft bases. This is the broad classification of hard acids, bases, borderline acids and bases, soft acids and bases. So here you can see in this picture, you can see the size of atomic radius, or the how the element ion size varies in if you move from left to right, or if you move from top to bottom. In this periodic table it is very clear. So this is a brief introduction, this is a brief explanation about the hard acids and soft bases. Thank you for watching this video.